April 13th, 2029. An asteroid, wider than the Eiffel Tower is tall, will pass so close to Earth that it will fly below our own satellites. Let that sink in, closer than the satellites orbiting above your head right now. Scientists named it Apophis after the Egyptian god of chaos and destruction. And when they first discovered it, their calculations showed a 1 in 37 chance of a direct hit. NASA scientists literally lost sleep over this. But here's where it gets really interesting, because 2029 is not what they're scared about. It's what happens after. You see, when Apophis passes Earth in 2029, our gravity will bend its path, reshape its orbit, and send it on a new trajectory through space. And nobody, not NASA, not ESA, not any space agency on this planet, can say with 100% certainty where it goes next. So the question isn't whether Apophis will pass Earth. It will in 2029, guaranteed. The real question is, what happens on its next visit? Stay with me, because what NASA found next changes everything. It was June 19, 2004. A team of astronomers at the Kitt Peak National Observatory in Arizona were doing what they do every night, scanning the sky, cataloging space rocks, looking for anything that might one day threaten our planet. And then they found something, a 340-meter wide chunk of rock quietly tumbling through space. They named it 99942 Apophis. At first, it didn't seem too alarming. Astronomers discover near-Earth objects all the time. Most of them are harmless. Most of them pass millions of miles away. But then they ran the numbers, and the numbers were wrong. Or rather, terrifyingly right. On Christmas Eve 2004, NASA announced to the world that Apophis had a 2.7% chance of hitting Earth in 2029. 2.7%. That doesn't sound like a lot. But in the world of planetary defense, that is catastrophic. That is the highest probability ever recorded for a space rock of that size. To put it another way, if you rolled a 37-sided dice and one side said end of civilization, you'd want to put that dice down very carefully. The story exploded across media worldwide. Scientists who had dedicated their careers to tracking asteroids were suddenly getting calls from government officials. Emergency briefings were held, contingency plans were discussed, and for a few weeks in late 2004, the world quietly panicked. But then something happened. Astronomers found older images of Apophis, archive photos taken before its official discovery. This gave them more data, more precise measurements, and when they plugged those numbers into their models, the probability dropped. From 2.7% to near zero for 2029, the world breathed a sigh of relief. The news cycle moved on. Most people forgot about Apophis entirely, but the scientists didn't forget. Because while 2029 was off the table, 2036 wasn't, and then 2068 and beyond. You see, Apophis isn't just one flyby. It keeps coming back, like a cosmic boomerang with terrible aim. And every time it swings past Earth, our planet's gravity nudges it, pulls it, changes it just slightly. And those tiny changes, they compound, they stack up. And over decades, they could mean the difference between a near miss and a direct hit. Let's talk about 2029, because what's going to happen that year is genuinely unprecedented. On April 13th, 2029, a Friday the 13th, because of course it is, Apophis will pass Earth at a distance of approximately 31,000 kilometers. That sounds far, it's not. Our moon is 384,000 kilometers away. Apophis will pass 10 times closer than the moon. Our geostationary satellites, the ones that power your GPS, your weather forecasts, your internet, orbit at around 35,000 kilometers. Apophis will pass below them. If you're standing in the right part of the world, Europe, Africa, parts of Asia, you'll be able to see it with the naked eye. No telescope needed. A tiny, fast-moving star streaking across the sky. It will be the first time in recorded human history that an asteroid this large has passed this close to Earth. And here's what makes it even more extraordinary. We've never been able to study an asteroid this closely, this safely, before. Multiple space agencies are already planning missions. ESA, the European Space Agency, has announced plans to send a spacecraft called Ramses to rendezvous with Apophis during the flyby. NASA is planning its own observations. Scientists want to watch what happens when Earth's gravity grabs Apophis. They want to see how it changes. Does it crack? Does it shed debris? Do boulders shake loose from its surface? Because this isn't just about 2029. This is about understanding what Apophis will do next. Here's what you need to understand about gravitational keyholes. A gravitational keyhole is a tiny region of space. If an asteroid passes through it, even grazes it, Earth's gravity will bend its path in exactly the wrong way, sending it on a collision course for a future flyby. The keyhole for Apophis in 2029 is less than 800 meters wide. 800 meters in the vastness of space. That's almost nothing. Current calculations say Apophis will miss the keyhole for 2036. It will miss the keyhole for 2068. It will likely miss Earth for at least the next 100 years. Likely, that word is doing a lot of heavy lifting right there. Because what we don't fully understand yet is something called the Yarkovsky effect. A tiny force created when sunlight heats one side of an asteroid and causes a minuscule thrust as it radiates heat. Almost invisible, almost immeasurable. But over decades, over centuries, it can shift an asteroid's orbit enough to change everything. And right now, our measurements of the Yarkovsky effect on Apophis aren't precise enough to say for certain what happens in 2068 and beyond. That's why 2029 is so critical. That flyby will give us data we've never had before. And with that data, we can finally answer the question that has haunted planetary scientists for 20 years. Is Apophis coming back for us? Now, let's talk about the thing that probably brought you to this video. The posts, the headlines, the panic. NASA warns, asteroid has 72% chance of hitting Earth in 2038. ISRO chief says we may all go extinct. Earth-destroying asteroid is speeding toward us. You've seen them. Maybe you even shared one. I'm not going to judge. Some of these posts look incredibly convincing. But here's the truth. The 2038 asteroid story is not real. There is no confirmed asteroid with a 72% chance of hitting Earth in 2038. That number does not exist in any official NASA database. It is not in the ESA's risk list. It is not in any peer-reviewed scientific paper. So where did it come from? In 2019, NASA conducted what they called a planetary defense tabletop exercise. A simulation, a war game. Scientists and government officials sat in a room and asked a simple, terrifying question. What would we actually do if an asteroid was heading toward Earth? They invented a fictional asteroid. They gave it fictional parameters, including a 72% chance of impact. They then ran through the entire scenario. How would we detect it? How would we communicate with governments? What options would we have? How much time would we need? It was an exercise, like a fire drill. Completely hypothetical. But somewhere along the way, someone took that 72% figure, stripped it of all context, and posted it as if it were real. As if NASA had actually discovered an asteroid with a near certain chance of impact. And the internet did what the internet does. It spread. Thousands of shares. Millions of views. Mainstream news outlets picked it up. Even some relatively reputable outlets ran with sensationalized headlines before quietly correcting themselves in the small print. The Times of India published a headline reading, NASA warns that a planet-sized asteroid has a 72% chance of impacting the Earth. And while they did clarify in the article body that it was a simulation, the headline was already doing damage. This is how misinformation works, not always through outright lies, but through context removal. Through headlines that are technically based on real events, but completely mislead you about what those events mean. And this matters, not just because it's wrong, but because it causes real harm. When people panic over fake asteroid stories, real science gets drowned out. When governments get flooded with calls about fictional threats, resources get diverted. When the public stops trusting official announcements because they've been burned by false alarms, that trust is almost impossible to rebuild. So yes, check your sources, read beyond the headline. If something is telling you that NASA has confirmed an Earth-destroying asteroid and nobody at NASA seems to be panicking, there's probably a reason for that. The real story is always more nuanced. And honestly, often more interesting. Alright, let's do something uncomfortable for a moment. Let's say, hypothetically, Apophis does hit Earth, not in 2029, not in 2038, but at some point in the future, some calculation is off, some measurement is wrong, and it happens. What would actually happen? Apophis is approximately 340 meters wide. That puts it in a specific category. Large enough to cause regional catastrophe, but not large enough for a global extinction event. To be clear, that is still extraordinarily, incomprehensibly destructive. If Apophis hit land, the impact would release energy equivalent to roughly 1,200 megatons of TNT. That's 80,000 times the bomb dropped on Hiroshima. The initial blast would flatten everything within a radius of hundreds of kilometers. The shock wave would travel further. The dust and debris thrown into the atmosphere would affect global temperatures for years. An entire country the size of Germany could be effectively destroyed by a single impact. But there's something that keeps scientists up at night even more than a land impact. An ocean impact. About 70% of Earth's surface is ocean. Statistically, if something hits us, it's more likely to hit water than land. When a 340-meter asteroid hits the ocean, it doesn't just splash. It punches through the water like it's not there and hits the seabed. The energy transfer creates tsunamis that dwarf anything in recorded human history. Waves hundreds of meters high, traveling at the speed of a commercial jet, slamming into coastlines across entire ocean basins. Coastal cities, gone. Port cities, gone. Low-lying nations, gone. The death toll from an ocean impact could run into the hundreds of millions. And this is why the Apophis flyby in 2029 is not just scientifically fascinating, it's existentially important. Because 340 meters is exactly the size where we really, genuinely need to care. It's too big to burn up harmlessly in the atmosphere, too big to deflect with a hand wave and a hope. But just small enough that with the right technology, the right warning time, the right plan, we might be able to do something about it. On September 26, 2022, NASA did something that has never been done before in the history of our species. They changed the orbit of an asteroid on purpose. The mission was called DART, Double Asteroid Redirection Test. A spacecraft roughly the size of a vending machine traveling at 6.6 kilometers per second slammed directly into an asteroid called Dimorphos. The goal was simple: nudge it, change its orbit by a measurable amount. Prove that we could do it. Before impact, Dimorphos took 11 hours and 55 minutes to orbit its parent asteroid, Didymos. After impact, 11 hours and 23 minutes. NASA had changed the orbit of an asteroid by 32 minutes, significantly more than their minimum target of 73 seconds. Let me be direct about why this matters. If you want to deflect an asteroid, you don't need to destroy it. You don't need to blow it up like in the movies. You just need to nudge it, even slightly, even barely. As long as you do it early enough, years, ideally decades before impact, even a tiny nudge will compound over time into a completely different trajectory. Miss the keyhole by a centimeter, miss the Earth by thousands of miles. DART proved we can do this. But DART was just the beginning. The follow-up mission, ESA's Hera spacecraft, was launched in October 2024. It's currently on its way to Dimorphos to study the impact crater in detail, to understand exactly how the asteroid responded, to refine our models for future deflection missions. Because here's the thing, DART worked better than expected. But we got lucky in some ways. Dimorphos turned out to have a loose rubble pile structure that amplified the momentum transfer. A denser asteroid might not respond the same way. So Hera is going to give us the data we need to know. For any given asteroid, what's the most effective way to push it? Beyond DART and Hera, NASA's Planetary Defense Coordination Office, yes, this is a real thing that exists and has a real budget, is actively developing multiple options for asteroid deflection. Kinetic impactors like DART, gravity tractors, which use a spacecraft's own gravitational pull to slowly tug an asteroid off course over years. Even nuclear detonations as a last resort, not to destroy, but to vaporize the surface and create a thrust effect. And critically, they are tracking, constantly, obsessively. NASA's Center for Near-Earth Object Studies monitors thousands of asteroids around the clock. Every known near-Earth object is tracked, catalogued, and given a probability assessment. The moment anything shows even a remote chance of impact, it goes on the watch list. The Vera C. Rubin Observatory, currently coming online in Chile, is expected to double the number of known near-Earth asteroids within its first year of operation. The more we know about, the more time we have. And time is everything in planetary defense, because there's one thing every expert agrees on. If we get enough warning, years, ideally decades, we can stop almost anything. The only scenario that truly frightens scientists isn't Apophis. It's the asteroid we haven't found yet. So, back to the original question. Will an asteroid destroy Earth in 2038? No. Categorically, definitively, no. Will Apophis hit Earth in 2029? Also no, but we are certain of that. Could Apophis pose a risk in 2068 or beyond? Possibly. The data isn't complete yet, and that's exactly why 2029 matters so much. But here's the thing I want you to take away from this video, and it's not the thing you might expect. The fact that we're having this conversation at all, that's remarkable. For almost all of human history, if an asteroid had been heading toward Earth, we would have had no warning, no plan, no choice. We'd have just been hit like the dinosaurs. We have telescopes scanning the sky every single night. We have a catalog of thousands of near-Earth objects. We have a spacecraft that has actually demonstrably changed the orbit of an asteroid. We have agencies around the world whose entire job is to make sure we never get blindsided. We are, for the first time in the 4.5 billion year history of this planet, a species capable of defending itself from space. That is not a small thing. The threat is real. It has always been real. It was real when the dinosaurs didn't see it coming. And it's real now, but for the first time, we're looking up. Apophis will pass us in 2029. Millions of people will look up at the sky and see it with the naked eye, a tiny bright dot moving faster than any star. And scientists will be watching it more closely than any asteroid has ever been watched before, measuring it, mapping it, learning everything they can about what it will do next. And if the data shows any cause for concern, we know what to do. DART proved that. So the next time you see a headline screaming about the end of the world, pause, take a breath, check the source, and remember, the real story is always more complex, more nuanced, and honestly, more incredible than the panic would suggest. That's it for this video. If you found this interesting, share it with someone who needs to see it.